Hey guys, in this lesson we would understand a new type of equation that is called a quadratic equation. Up till now we have covered up linear equations or linear relations and have solved linear relations using different problems. Now there is a new type of relation that we will be learning and it is called quadratic relation. How is quadratic relation different from a linear relation is, we know when we write on a linear relation or a linear equation in the form of slope and intercept, it is y equal to mx plus b form. The equation is y equal to mx plus b. When we call this linear, the reason we call this equation as a linear equation is because the x, that is the independent variable, has a power of 1 in this case. So when x or the independent variable has a power 1, the equation is called a linear equation. However, when the degree of x is 2 or the maximum power of x is seen to be 2 in an equation, then that equation is called a quadratic equation. We notice that there is another x term in this equation. Although this x term has a power of 1, but we do not call this equation as a linear equation because the name of the equation is decided on the basis of the degree of the equation. Degree is the highest power that we see for x, and the highest power in this case is 2, so it is called a quadratic equation. In this case, the highest power of x is seen as 1, so this is called a linear equation. Now, as we know, linear equations were written in two different forms. One is slope-intercept form, that is y equal to mx plus b form. These are the general linear equations that we are talking about. The second form of the linear equation is standard form. Standard is ax plus by plus c equal to 0 form. The reason we are talking about different forms of equations of a linear equation is to understand that quadratic equations also have different forms that it can be written down in. Linear equations has two forms that it can be written down in, whereas when it comes to quadratic equations, there are three forms that it can be written down in. First is called the standard form, second is the vertex form, and third is the factored form. Let's take up these three forms of quadratic equations and understand their general equations. And in later lessons, we would be dealing with each of these forms individually in details as well. So the first form of a quadratic equation, that is called a standard form, is the form in which the equation is written as y equal to ax squared plus bx plus c. A, b, c are the constant values and x is the independent variable. Second form is the vertex form, and the equation for vertex form is y equal to a x minus h squared plus k. In the vertex form, a, h, and k are the constants. Third form is called the factored form. In this case, the equation is y equal to a x minus r x minus s. Here A, R, and S are the constants. So all the alphabets that are underlined, they are the constant values, means they would have a numerical value to them when it comes to specific equations. Now, so far, when we compare linear and quadratic equations, we see linear equations can be written in two forms. Quadratic equations can be written in three forms. Linear equations have degree of 1. Quadratic equations have degree of 2. There is another comparison for linear and quadratic equations, and that is when we are given the table of values for linear and quadratic equations, we would see a difference of finite differences in each of these equations or table of values. Let's understand this with an example. Let's say we are given these two table of values, and using the table of values we are asked to figure out which of these two table of values represent a linear equation table of values and which of these represent a quadratic equation table of values. So we have to identify linear and quadratic table of values in the following two tables. Now how do we solve this type of question is, we find out the common differences for y value. This is called finite differences. We are finding here first finite difference, and how do we find out the first finite difference is, we just have to subtract the y value with the previous y value to find out the difference between the two y values. Here we notice we get is 9 minus 5 is 4. Then the subsequent values of y will be subtracted from the previous values in the same way. 13 minus 9 is 4. 17 minus 13 is 4 as well. We notice here that the first finite differences are equal. If the first finite differences are same, then the given table of values belong to a linear equation. So this table represents a linear equation table. Let's check the first finite differences. For the second table, when we subtract 5 and 2, we get a 3. We subtract 10 and 5, we get a 5. When we subtract 17 and 10, we get a 7. We notice here that the first finite differences are not same. When the first finite differences are not same, then we do the next step, and that is find the second finite differences. The second finite differences is the differences of the first finite differences. Always remember, we subtract the top number from the bottom number. So this is going to be 5 minus 3, which is 2. 7 minus 5 is again a 2. And we notice here that the second finite differences are same. If the second finite differences are same, then this table of values would represent a quadratic equation. Just in case there is a scenario where none of the first or the second finite differences are same, then we say it's neither a linear nor a quadratic relation table of values. And this is how we find out if the given table of values belong to linear or quadratic equation using the finite differences.